Okay, Ji, Bismillahirrahmanirrahim. So I'm going to start off with like the questions. I'm going to help you out in some of these questions. It says, I have 8 questions planned. These are in your past papers. Please take out your past papers and be solving these. Okay. It says a dentist uses a plane mirror. A plane mirror, you need to understand, it reflects. It's a reflective surface, so it's going to reflect light rays off it, right? It says to see the backward tooth, a plane mirror produces an image of an object. Describe the position of the image. Now we talk about characteristics of image produced by a plane mirror. The first is obviously it is virtual. Second is it is formed behind the mirror because we talk about position. So ये वाला point count करेगा. Formed behind the mirror. And the second, because it's a two marker, the second pointer would be the object distance is equal to the image distance. So the distance of the object is equal to the distance of the image from the mirror. Distance of the image from the mirror. Now, figure 6.1 shows a plane mirror used by dentists to see the point labeled X on the tooth. Because it's a mirror, so laws of reflection follow करेंगे, right? So what I'm going to do is I'm going to take out a ruler, and it says on figure 6.1, mark the position of image X formed by the mirror. Position of image X formed by the mirror. You need to understand that there would be rays coming out of this point and going into the eye. However, the image is formed because it's a plane mirror. The image is formed behind the mirror. So you can make a line like this. The distance of the image should be by eye at equal distance from the mirror, right? So this should be your image behind the mirror, okay? So this is how rays are reflected. Images are formed behind the mirror, okay? Next is draw a ray of light from X to show that the dentist can see the tooth. So this is the ray of light that comes from point X, reflected from point X and back into the eye of the observer. It says, state one characteristic of the image formed by a plane mirror other than its position. So we talked about uh, um, the image being virtual. We can talk about the image being laterally inverted. We can talk about, in this point, we can talk about the image being virtual. The image size is equal to the object size. So even if you see in the mirror, you won't appear to be bigger or smaller. The image size is equal to the object size. So whatever your size is going to be the size of the image as well. Next is question number 2 from your past papers. So I'm going to go on to question number 2. It says two mirrors. Again, it's a mirror, so laws of reflection only, okay? Where the angle of incidence is equal to the angle of reflection. This ray of light that you see here, uh, so this ray of light that is incident on mirror A, we call this the incident ray. ये mirror पे fall कर रही है, we call this the incident ray. जहाँ ये fall करती है, this is what we call the point of incidence. At this point, you should draw a normal. The normal should be 90 degrees to the surface. The angle formed between the normal and the incident ray is the angle of incidence. So if it's a 90 degrees, this angle is 30, then the angle of incidence is 60 degrees. If the angle of incidence is 60 degrees, the angle of reflection also has to be 60 degrees. Now it says determine the angle of incidence at mirror A. The angle of incidence at mirror A is 60 degrees. Now it says determine the angle of incidence at mirror B. If you look closely, this ray that is reflected from mirror A goes on to mirror B, and can I say that this is traveling along the normal? It is the normal itself, right? So traveling along the normal. So you need to understand that the ray is perpendicular to mirror B. Perpendicular means it hits the surface at 90 degrees. So the angle of incidence at mirror B has to be 0 degrees because there is no angular movement. The ray of light is traveling along the normal. Okay. Next is describe the path of the ray of the reflected ray after it leaves mirror B. So if we talk about reflection from mirror B, ray goes this way. Ray is going to be reflected along the same line, right? Along the normal. So it says it's a one marker. You have to describe the path. travels along the same path in a different direction. So जैसे इंसिडेंट रे हिट कर रही थी उसी तरह रिफ्लेक्टेड भी होगी बट along the same path in the opposite direction. Okay, because वो रिफ्लेक्ट होके वापस इसी तरह मूव करेगी. Now it says a plain mirror hanging on a wall is used to form the image of an object. It says state three characteristics of image formed in a plane mirror. That's virtual. That's laterally inverted. Laterally inverted का मतलब है left becomes right, right becomes left, and then the object size is equal to the image size, and the distance of the object from the mirror is equal to the distance of the object from the mirror. ये सारी चीजें होती हैं, and it is formed behind the mirror. So you can write down. हमने तो तीन कैरेक्टरिस्टिक लिख दिए, हम तीन चार लिख देते हैं. Image is formed behind the mirror. Next is, let's move on to the next question, sir. Just give me a minute. Now, let's move on to the next question. The next question is, the three angles of glass prism are 45, 45 and 90 as shown in figure 4.1. ठीक है, अब बगैर इसको देखें, if the ray of light enters perpendicularly, it does not undergo refraction. ये bend नहीं होगी, ये सीधी चलेगी. So if this is 90, this is also 90. If this angle is 90 degrees, this is 45. Then can I say that this angle is also 45? Calculations कर लें आप calculator पे, you'll find this to be 45 degrees. Okay. Now it says at point Y. Let's look at point Y. A ray of light of a single frequency. When we talk about ray of light of single frequency, we're talking about a monochromatic ray. Monochromatic ray is defined as a ray of light with single frequency. Travels in air and strikes the inside of the prism at 90 degrees. The ray passes into the glass prism. Okay. Light rays travel more slowly in glass than in air. Yes. State what happens to the wavelength of the light in the ray as it enters the glass. Now you need to understand all rays, whether it is a light ray or whether it is a sound wave. The formula is V equals to wave velocity formula is V equals to F lambda. Wave frequency depends on the illuminated source. मतलब light source पे depend करता है. तो 30 वॉट का बल्ब लगाओगे उस पर कम लाइट होगी, या 100 वॉट का लगाओगे तो ज्यादा होगी. So light की frequency does not change. Frequency for light and sound does not change. ये याद कर लो. Now if this is constant, then as velocity increases, wavelength increases. तो wavelength और velocity जो है ना directly proportional हो जाता है. तो जैसे ही wavelength बढ़ेगी, velocity बढ़ेगी. जब wavelength कम होगी तो velocity कम होगी. Now it says, as it travels from one medium to another medium, part 2 पहले कर लेते हैं. Shape what happens to the frequency does not change, stays constant. Then it says shape what happens to the wavelength. Sir, अगर light slow move कर रही है ग्लास में, तो लाइट स्लो मूव कर रही है तो वेलोसिटी कम है, और अगर वेलोसिटी कम है तो वेवलेंथ भी कम हो जाएगी. तो वेवलेंथ रिड्यूसेस, द वेवलेंथ डिक्रीजेस. ओके. नेक्स्ट इज द रिफ्रैक्टिव इंडेक्स. नाउ व्हेन वी टॉक अबाउट रिफ्रैक्टिव इंडेक्स, इसके चार फॉर्मूले लिख रहा हूं, प्लीज अभी नोट डाउन कर लो. रिफ्रैक्टिव इंडेक्स इज साइन आई ओवर साइन आर. व्हेन वी टॉकिंग अबाउट the second medium, we're talking about the second medium, we say that the refractive index sin I upon sin R. When we talk about the first medium, it is sin R over sin I. And when we talk about critical angle, so critical angle and refractive index is connected to refractive index equals to 1 over sin C. And when we talk about speeds of light, the formula is C upon V, where C is what? The speed of light in air or vacuum. Speed of light in vacuum or air, which is 3 into 10 power 8 upon speed of light in the medium. जिस मीडियम की बात कर रहे होते हैं उसमें स्पीड ऑफ लाइट कितनी है. ओके, लेट्स सी इसमें क्या अप्लाई होता है. लेट्स गो बैक टू द क्वेश्चन. सर, एक लाइट रे एयर टू ग्लास ट्रैवल कर रही है. एयर जो होगा वो फर्स्ट मीडियम होगा और दिस ग्लास प्रिज्म इज द सेकंड मीडियम. यू विल हैव टू आइडेंटिफाई कि फर्स्ट मीडियम है या सेकंड मीडियम है जिसकी बात कर रहे हैं. नाउ इट सेज, मैं हाईलाइट करके दिखाता हूं. इट सेज द रिफ्रैक्टिव इंडेक्स ऑफ ग्लास. तो ग्लास हियर इज द सेकंड मीडियम. तो रिफ्रैक्टिव इंडेक्स का जो फॉर्मूला रहेगा वो सेकंड मीडियम का फॉर्मूला रहेगा. मैं इसको हाईलाइट करके आपको दिखाता हूं. सेकंड मीडियम का फॉर्मूला इज sin I over sin R. sin I over sin R. Now I'm going to apply the formula. अगर तो एंगल ऑफ इंसिडेंस मांगे या रिफ्रैक्शन मांगे तो सेकंड मीडियम का फॉर्मूला. बट व्हाट इज द क्वेश्चन आस्किंग? The question is asking about the critical angle. When we talk about critical angle, refractive indexes and critical angle are connected through refractive index equals to 1 over sine theta. So the refractive index answer is given to me. That's 1.6. 1 upon sine of this critical angle. अब sin c निकालना है. इसको उधर ले जाते हैं. 1.6 comes down. So sin c would be equal to 1 upon 1.6 and c equals to sine inverse of 1 upon 1.6. इसको कैलकुलेटर में करोगे तो तुम्हारे पास आंसर आ जाएगा. Let's look at the answer. It is 39 degrees. I don't have a calculator right now, so 39 degrees is the answer. Now, if your critical angle is 39 degrees, तो बेटा अगर आप critical angle का डायग्राम बनाते थे इस तरह, this is the normal, एक ray of light है, ये normal bend हो रही है, इसको और further push करोगे, and if it starts traveling along the plane, देखो मैं बना के दिखा रहा हूँ, if it starts traveling along the plane, तो ये जो angle of incidence होता है ना, यही critical angle बन जाता है, understood? The refracted ray travels along the plane, or the angle of refraction becomes 90 degrees. और अगर थोड़ा सा और पुश करें तो ये टोटली इंटरनली सेम मीडियम में रिफ्लेक्ट बैक हो जाता है, राइट? सो इफ योर क्रिटिकल एंगल इज 39 डिग्री, हम देखते हैं लाइट स्ट्राइक्स द प्रिज्म एट जी. जी पे एंगल ऑफ इंसिडेंस कितना है? दिस इज जी. सो इफ यू लुक एट जी, दिस इज द पॉइंट ऑफ इंसिडेंस एंड यू विल हैव टू ड्रॉ द नॉर्मल दैट इज 90 डिग्रीज टू द सरफेस. सरफेस के 90 डिग्री होना चाहिए. तो ये एंगल ऑफ इंसिडेंस होगा. If this is 45, all of this is 90. Can I say the angle of incidence is also 45? If the angle of incidence is 45 and the critical angle is 39, can I say that angle of incidence is greater than critical angle? And if this happens, then the light is totally internally reflected. Total internal reflection occurs. Light does not escape back into air. ये वापस इसी medium में आ जाती है. Sketch the path of the light after it strikes the side of the prism. So it is reflected back into the same medium. और जब रिफ्लेक्शन होगी तो एंगल ऑफ इंसिडेंस और एंगल ऑफ रिफ्रैक्शन बराबर होना चाहिए. दिस इज 45, दिस इज 90 and this goes back into air. Because it is exiting the prism at 90 degrees, this means it does not bend, it does not undergo refraction. Let's move on to the next question. So, you have figure 3.1 shows the light entering a transparent block. This is the angle of incidence. This is the angle of refraction. जो normal और refracted ray के साथ हो वो refraction होता है. ये पाई, ये जो symbol है ना बेटा, इसको हम पाई कहते हैं. ठीक है, कोई भी नंबर, कोई थीटा लिख लो, अल्फा लिख लो, बीटा लिख लो, गामा लिख लो, पाई लिख लो, doesn't matter. ये angle है. However, the angle of refraction, this is not the angle of refraction, right? It says light enters the block at angle theta, ये given है, ठीक है जी, to the normal and travels through the block until it meets the bottom surface. यहाँ पे bottom surface पे meet कर गए. The angle between the ray in the block and the vertical side of the block is pi. ये भी हमने देख लिया. Light travels more slowly in the block. अगर light slow travel कर रही है, you need to understand v equals to f lambda connected है, frequency change नहीं होती. अगर light की velocity कम हो रही है तो उसकी wavelength भी कम होगी. Light travels more slowly in the block than in air. Explain how figure 3.1 shows this. अब देखते हैं. इसको जाना चाहिए था. अगर तो कोई resistance नहीं होती, it should have gone straight. It has bent towards the normal. This bending only occurs because of the changes in speed of light in different medium, right? तो आप क्या बोलोगे? Explain. This is the 2 marker. आप इस पे इसका मार्किंग थीम भी पढ़ते हैं इसका, बट आप देखोगे refraction occurs when the ray hits the surface. इसका एक मार्क. एंड फिर बताना होगा कि it is towards the normal या away from the normal. It is towards the normal. This means the speed slows down. Speed कम हो जाती, speed decreases. Say what happens to the frequency. पहले देख लेते हैं. Frequency does not change. It stays constant. Stays constant, right? And then you have wavelength. Wavelength देखो बेटा, speed कम होगी ना तो wavelength भी कम हो जाएगी. तो wavelength decreases. Will you remember this? ठीक है जी. The refractive index, ये बड़ा important question है. This is a very important question. Please pay attention. It says the refractive index of transparent material. अब transparent material जो है ये वाला transparent block, इसमें right A to transparent block आ रहा है. तो this is your second medium. Look at the arrows. Arrow indicate करेगा कि A to medium आ रहा है. A to the transparent block आ रहा है. तो second medium का formula है. एंगल थीटा इज 45, एंगल थीटा इज द एंगल ऑफ इंसिडेंस, ठीक है जी। हम रिफ्रैक्टिव इंडेक्स निकालते, रिफ्रैक्टिव इंडेक्स इज साइन आई ओवर साइन आर, बिकॉज ये सेकंड मीडियम की बात कर रहा है, बिकॉज ट्रांसपेरेंट मटेरियल इज द सेकंड मीडियम, अंडरस्टूड। साइन रिफ्रैक्टिव इंडेक्स आंसर गिवन है 1.6, साइन ऑफ एंगल ऑफ इंसिडेंस है 45 अपॉन साइन ऑफ आर निकालोगे, आर पहले निकलेगा, उसके बाद उसको 90 से माइनस करोगे तो 5 निकलेगा। 1.6 को उधर मूव कर देते हैं, साइन आर को इधर मूव कर देते हैं, साइन आर इक्वल्स टू साइन 45 डिवाइडेड बाई 1.6। तो आर की वैल्यू मैं तुम्हें कैलकुलेट करके बताता हूँ सर। आर इज 26, द एंगल ऑफ रिफ्रैक्शन इज 26। देखो बेटे, ये वाला एंगल जो है ना, दिस इज 26, व्हाट इज द एंगल फाइव, दैट इज, ये पूरा 90 बनता है, तो 90 माइनस 26, therefore phi is 90 minus r, 90 minus 26, which is 64 degrees. Next is the angle of incidence I at the bottom of the surface is equal to phi. देखो जो एंगल ऑफ इंसिडेंस है ना बेटा, यहाँ पे जो बना हुआ है, ये 64 डिग्रीज है, ये इक्वल टू पाई है, ओके। इट सेज एंड द क्रिटिकल एंगल इज 39। मेरा बेटा अगर क्रिटिकल एंगल, एंगल ऑफ इंसिडेंस है 64 और क्रिटिकल एंगल है 39, अगर क्रिटिकल एंगल ऑफ इंसिडेंस ग्रेटर देन क्रिटिकल एंगल हो तो टोटल इंटरनल रिफ्लेक्शन हो जाती है, रे ऑफ लाइट जो है वो एग्जिट नहीं करती, सेम मीडियम में वापस अंदर आ जाती है। एक्सप्लेन व्हाट हैपेंस टू द लाइट आफ्टर इट मीट्स द बॉटम सरफेस। इट इज, देखो आंसर पढ़ो, दो मार्क्स का है, तो पहले ये स्टेट करना हो, एंगल ऑफ इंसिडेंस ग्रेटर देन क्रिटिकल एंगल, दैट इज 64 डिग्रीज इज ग्रेटर देन 39 डिग्रीज एंड टोटल इंटरनल रिफ्लेक्शन आता है। इसलिए मैं मिनट, फिर हम नेक्स्ट क्वेश्चन पे जाते हैं।